All right, we're back. Hopefully you did well on that. Let's go through an answer for this. It says a piece of cardboard 30 centimeters long and 25 centimeters wide is used to make a box with no lid. Similar kind of question. Equal sides, squares of side length x are cut from the corners and the sides are folded up. Write a polynomial function to represent the volume of the box in terms of x. Okay, so if we're told we want to call the polynomial function v, and we want it in terms of x, so I can say v of x is equal to, and we're already told that the side length is equal to x. So this is the length part here. I'll just remind myself I'm doing length times width times height. So that's my first part, is the x is the length, and then it says that it's 30 by 25, so very similarly the width will be 25 minus 2x, just thinking about that diagram that we used for the example a minute ago, and then the height, or no, what are we left with? Length, width. I'm getting my dimensions mixed up. I guess I did x would be the height afterwards. I did the height first, and then this is the width, and then last would be the length, 30 minus 2x. And it doesn't matter which order that you put those polynomials in. There's the first part. That's the answer to A. Let me see here. Okay, the answer to B, it says graph the function. What is the domain? Okay, I'll just cheat and look at their answers here. It says enter the equation this into a graphing calculator or graphing software. The side length of a square cut from each corner must be less than 25 centimeters over 2, or 12.5 centimeters. So how do they know that? Well, even before you type it into your graphing calculator, looking at our 3 dimensions, the rule is that all 3 dimensions have to be positive, have to be greater than 0. So the restrictions on the first one is that x has to be greater than 0. Can't be equal to 0. I won't make that mistake again. So that's from the first dimension. From 25 minus 2x, 25 minus 2x also has to be greater than 0. So if I go minus 2x is greater than minus 25, you'll notice I don't change the sign when I'm adding or subtracting. The rule for changing the sign is when I'm multiplying or dividing by a negative value. So this is coming up now. So I'm going to divide both sides by negative 2. So now I'm going to get x is less than negative 25 over 2, or negative 25 divided by negative 2. So that gives me the positive 12.5, or 12.5. So that's my first restriction. Let's take a look at the last restriction. 30 minus 2x has to be greater than 0. This is very quickly here, so you're going to get x has to be less than 15. So if x has to be less than 12.5 and x has to be less than 15, really these two collapse just into saying x has to be less than 25. So my domain, here's the best way to write it. X has to be greater than 0 and x has to be less than 12.5, so you can write it all in one statement like this. 0 is less than x, which is less than 12.5. Best way to write it. Part C is they're going to ask you to find out what is the volume. The box has a maximum volume of approximately 1,512 cubic centimeters when each square that is cut out has a side length of approximately 4.5 centimeters. So how do you get that answer? You get it from plugging it into your graphing calculator or into the software. And then the approximate dimensions are. So where do you get these approximate dimensions? This 4.5 is the x value that you got from the highest point, 4.5, and then the width, you plug in the 4.5 into each of these. So 25 minus 2 times 4.5, 30 minus 2 times 4.5. So we get 16 and, I have to scroll down to peak. We get 16 and 21 as our two answers. So those are the dimensions. Okay, you'll definitely be seeing questions like that. And do we have one more example? Example number 2 is our last example of the lesson. Now this is a graph of a quartic function. So if you recall, quartic function is when we have degree 4 for x. So our last one we had 3 dimensions, so it was really a cubic. It was x cubed if we were to multiply those out, although it was kind of in factored form, wasn't it? Now we're going to have a quartic function. Here, I'm going to hide this solution because we're going to be looking at it in a second. Leo and 3 friends, so 4 people altogether, quartic function, 4 friends, each have birthdays on December the 13th. Sanda is 3 years younger than Leo, Leo is 4 years younger than Vince, and Hunter is 1 year older than Leo. So the big thing that pops out at me when I'm reading this piece here is that everything is defined according to Leo. So Leo is the key, and that's why in the solution you're going to say let Leo's age in years be x. Okay, I usually write it actually the other way. I'll say let x equal, and then I write Leo's age in years. Okay, so you could say Leo's age. It's even better to say years because you're including the units. It's kind of like science class, right? Remember the units. So reading that first sentence, I'm thinking, okay, Leo is going to be my x. Leo would be my variable because then everything else is defined in terms of Leo. On December the 13th, 2010, the product of their ages was this amount greater than the sum of their ages. How old was Leo and each friend on that day? Okay, so this December 13th, they're not trying to make things more complicated. They're trying to make things a little bit easier. They're saying they all have their birthday on the same day. So on that day, you don't have to worry about, oh, somebody hasn't turned their age yet and things like that. It's going to work easily. So they're actually simplifying it by making this December the 13th and this December the 13th. And I don't think they're going to be doing trying to do any tricks here. So if you look at the check your understanding, they're going to do the same thing. They're all born on March 11th. So now March 11th, how old? So the product, let me read on. The product of their ages was this amount greater than the sum of their ages. So we want to make a statement, a mathematical statement out of that. So this is sort of the key. The product of their ages. So you're going to multiply Leo's age, which is x, and then Sanda's age. I don't know why it's not Sandra. Sanda's age. So Sanda is 3 years younger than Leo. So Sanda's age is x minus 3. Leo is 4 years younger than Vince. So just the way I would translate that into math, Leo is x, right, equals 4 years younger than Vince. So Vince minus 4. So then when you find out what Vince is, so x equals 4 years younger than Vince, so it would be Vince minus 4. So then what's Vince? Vince would be x plus 4. So that's where this comes from. Vince's age in years is x plus 4. Hunter equals 1 year older than Leo. So Hunter is x plus 1. So the sum of their ages would be Leo, Sanda, Vince, and Hunter. That would be 4x plus 2. And now reading this statement here, the product of their ages, here it is. This is the product of their ages. Each of those terms multiplied together is this amount greater than the sum of their ages. So this key sentence here is written out in math form over here. The sum of their ages, 4x plus 2 plus blah, 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 equals all that. All right. So at this point you might say, how the heck am I going to graph that? Well, we're going to find out when this statement is true by putting all the terms on one side. So we have a 0 equals that. And now we can say this statement is true when the right-hand side is equal to 0. Okay, does that make sense? So we're wondering, when is this true? For what values of x is this true? Well, if we mathematically make some changes to both sides, in this case subtract 4x, subtract 2, subtract our 54,000 from both sides. So this is really the identical statement. So when is this true? Well, if we graph this, and just below you got a little bit of this graph. If we graph this and we find out when is this equal to 0, well, that's when it would cross the x-axis. Right? So at this point here, you have some positive value for x, and this entire expression, that's like my y value, is equal to 0. So that's the x-intercept. Why would this be the right answer and not this? The answer is, here you've got a negative x value, and all of your ages have to be positive. So x has to be positive, here x has to be at least 3, here x has to be greater than negative 4, here x has to be greater than negative 2. So when you're looking at all that, x has to be, the domain of that would be x has to be greater than 3, and looking at all those functions. So they get on their, let me just scroll down a little bit, checking their graphing calculator here. They use the trace and they say, okay, where's that x-intercept? It's at 15. So Leo was 15 years old on that day, and then you can figure out the other people's ages. So if Leo was 15, then Sanda was 15 minus 3 was 12. Whoever was this? Vince. Vince was 15 plus 4, so that's 19, and Hunter was 16. And there's the ages. Okay. Now it's time for you to try the Clara and 3 friends. So I'm going to pause this again.